Hi everyone, thanks for joining again. So I'm Fraser again. I'm sure a lot of you will have been to the previous webinars. I'm the Associate Director here at HebHomes. So thanks everyone for joining. I'm joined by Robin Torrie of Luths Services as well. So he's kindly given us a bit of his time to join me on the webinar to help me present it. So hello Robin, thanks for joining.
Hi Fraser, hi, good to see you.
You too. So this is, for those of you that don't know, I see there's quite a few people that have joined previously. So great to have you back, but nice to meet all the new people that have joined. So this is part of our monthly webinar series, and it's our self-build series, and it's really designed to give you a bit more knowledge and a bit more understanding about what you're getting into when you're thinking about a self-build. So looking at various different topics in a lot more detail. This one is one day late. We try and do one every single month. This is the April webinar, which is run into the 1st of May, just due to annual leave and things. So there will be another one towards the end of May. So today is all about, it's called Building Sustainable Futures. So it's all about how we build sustainably and what we think about when we're designing these houses to offset energy and make sure we're building really high quality energy efficient homes. As usual, the session will be recorded, so keep your mics off and videos off, and it will be uploaded to YouTube and the website as well afterwards, so people that haven't managed to drop in today can catch up, or if you miss something you can always go back over it. We'll allow time at the end as well for questions, but just put your questions through on the chat as well, so we can hopefully answer a few of them as we go through the process, but we'll certainly leave time at the end to answer your questions. So a little bit on, so Robin, as I say, works for Luths Services. They specialise in building services and energy assessment. Robin leads up the domestic team there, and he's a qualified SAP energy assessor and passive house consultant. So HebHomes and Luths, we've worked together for a long time now, and we work with Luths on all of our jobs. And it's really to assess and optimise the energy performance of each and every home. So that's taking into account site considerations and the actual house design and all your design choices. So Luths work with us on every design, and they help us with things like SAP reports, overheating analysis, U-value calculations, and also options appraisals for your heating and your hot water. So we'll be looking at things like the building fabric, energy performance, moving towards passive house, heating and ventilation, wood burning stoves. So that's the new hot topic. So we'll be covering that. In Scotland, it's a hot topic, pardon the pun, and a little bit about solar gain. So that's a kind of brief summary of what we're looking at today. So let's get stuck into it. So sustainability is obviously one of the most important things when you're building a home, what you need to think about, and it's always been at the heart of what HebHomes has had at its offering, and it has helped guide us to the systems that we have in place just now. And there's obviously a big drive to bring the current building stock up to scratch with regulations and basically improve the thermal efficiency of our homes. There's various different percentages out on the internet about how much homes can contribute to global warming and carbon emissions, but it looks to be around about 20% of UK emissions are from housing of some sort. And that's really because we have some of the oldest homes in Europe, but also some of the worst, most poorly insulated homes. So there's a lot of energy that people put into the homes goes straight out the walls, straight out the roof, and they just need to keep pumping energy into the homes to keep them warm. So there is a whole industry movement, and there has been for a couple of decades, towards much more highly insulated, airtight homes, and more recently moving entirely away from fossil fuel-based systems. So moving away from boilers, gas, oil, all that kind of stuff, and moving more towards electric systems. And there's also currently, well, in the next kind of decade or two, we're seeing the government bring in legislation that is focusing on existing housing stock. So it's they're aiming to try and bring the housing stock up to much better standards with insulation and air tightness. So it'll mean that people are having to pay to insulate their homes and try and increase the air tightness and just really increase the energy performance of their homes. So all of that is up for debate at the moment. We still don't know exactly what that's going to look like, but it is clear that they're taking a view on old housing, because a lot of the legislation and building regulation change that has happened over the last couple of decades is just to do with new builds. So there's a big drive towards improving the old housing stock. And as I say, HebHomes, from the outset, we've been trying to lead the way in how we build these homes, and the trying to exceed standards where we can. So looking at very good thermal efficiency, good air tightness, and really good design to allow you to easily heat your home, and you're not wasting that heat through the building fabric. And obviously the quality is extremely important, because you don't want to build a house that isn't going to be there for years and years and years to come, because you obviously put a lot of energy and a lot of materials into building these homes. We need to make sure that they're fit for purpose, and they're going to be standing for future generations, and they'll be setting a good example of what buildings should be like. So that's just a kind of whistle-stop tour of why we do what we do and how we try, and the kind of context that we're building in is really important to understand, and making sure that we're building high quality, energy efficient homes. So the building fabric is the first thing you need to think about. So we will be looking at heating systems and ventilation and things like that. But a lot of these systems do rely on you having really good thermal performance. So we've got the two systems. We've got SIP and we've got the CPS, which is a space frame, a space stud, so a wide timber frame. And they're both aimed at getting really good insulation, really good U values, and really good insulating properties, and really good air tightness as well. We have gone through the difference in previous webinars between SIP and the space frame, but the SIP is essentially a rigid insulation sandwiched with two sheets of OSB, and then the space frame is a wide timber frame stud using mineral wool insulation. So they're slightly different systems. Obviously, the SIP, you've got rigid insulation in it, and the space frame has the mineral wool. So both of them have really good thermal properties. So your U values are quite low in both. So the SIP, you're getting a 0.16 generally with insulation back plasterboard, but that can vary with, if say you go for block render on the outside. And the space frame, you're getting about between 0.13 and 0.15 for depending on the cladding. Again, the kind of main benefit to go into the CPS/space frame is the thermal bridging properties, because you have the thermal bridge is essentially something that's not insulation, so generally it's structure. It's part of how the house is built, and that spans the gap between the outside and the inside. So on this image, you can see the timber studs, and you've got a small horizontal tie. So that's essentially a thermal bridge where heat can travel through from inside to outside. And the less of those that you have in a wall build-up, the better. So that's why the space frame CPS system has superior properties when it comes to thermal bridging, because you don't have as many timber breaks between each panel. So you're really just trying to retain that the heat inside without it leaking out. Another thing we focus on is air tightness. So you notice if you're in an old home, which a lot of people are, there you might be in an older home which has drafts and you've got air leakage, and you've essentially got the level of heat in your home just slowly leaking out through gaps in the windows, trickle vents, and just general leakiness in the fabric of the building. So this is something Robin will probably touch on later as well, about the kind of passive house principles. We don't work to passive house, but we can talk about how we kind of use the very, very similar principles. But the air tightness is there just to keep all that heat in. And obviously with that, you need to make sure you're getting ventilation to the space. So we will be speaking a wee bit more about ventilation. And we often do get asked questions about the lifespan of our buildings, and it's the same as any other timber frame building. So in Scotland, we generally build with timber frame, and in England, it's much more, it seems, concrete block and different systems. But timber frame is slowly expanding in England, so it's becoming a much more common and popular system. But with timber frame, it'll be it's very much the same as our systems, as long as they're well maintained and you don't have any, you don't have the kit sitting in dampness and you don't have any leaks or unaddressed leaks. Your house will be there for decades and decades to come. There's no reason why it wouldn't. And you've got high quality membranes on the outside to make sure that you keep, the systems nice and dry. And finally, on this slide, usually when people are getting finance, so like mortgages or anything, they will generally they'll require to have some kind of warranty applied to the product, and usually it's a third party warranty that's required. So the third party warranty, usually something like NHBC, they would come and inspect the build at key stages throughout and make sure that they're happy with the build essentially, and then they issue you with the certificate at the end, which is then provided to the lender. Robin, do you have anything you want to add to this slide, or will you touch on some of these later?
Not at this stage, no, it's okay.
Okay. And energy performance, so this really is Robin's bag, so I'll let you take a bit of a lead on this, Robin.
Sure.
Because Luths basically prepare SAP calculations, EPC ratings, all that kind of stuff. So Robin, do you want to take a wee lead on this one?
Yeah, that's absolutely fine. Yeah. First of all, I should just say, of the slides that I've got to present, there's quite a lot of kind of engineering, technical detail and 3-letter acronyms and things like that. So there's also quite a lot of detail to try and get through. So hopefully for some of you, there'll be certain things that you've thought, I really need to know about that, and I've been asking questions about that. So hopefully there'll be something relevant, but there may well be sections that aren't so relevant to what you're thinking about. But I'll try and go through everything so that there's something relevant for everyone. So first of all, I guess that most people have heard of the EPC. All new homes have to have one now for your completion certificate. It's an energy performance certificate, and it's a measure of the estimated energy costs for running that home. So every house is issued with one after a SAP, what's called a SAP, which is just the piece of software, the methodology for calculating the EPC rating is carried out. Every house is scored out of 100, A rating, B rating, C rating, and worse. And the report will also give you recommended measures for improvements and cost savings. So this is the EPC is what you have at the end of the process. If you score 100, then that's saying that your house will cost nothing to run. You can actually have more than 100 if you have a lot of solar panels, because you're actually producing more energy than you're using. But most houses will be somewhere around 80 or so, something like that. So the SAP, which is SAP, that is used in Scotland and England. England is changing to something called the home energy model, but essentially it's going to be the same process where CO2 emissions and the energy requirements are measured for a new house. And in Ireland, they use something similar. They have this thing called the NZEB, or nearly zero energy building principle, but instead of SAP, they use something called DEEP, which is the Domestic Energy Assessment Procedure. It's all the same sort of thing. It's a process for considering the efficiency of the house. The SAP will look at things like the U values for your floor, walls, roof. It'll look at the thermal bridging that Fraser mentioned, lighting, ventilation, heating, hot water, whether you've got solar PV. So these are the factors that get looked at within the SAP. There are some differences between Ireland, England, Scotland. The main one is probably Scotland sits apart a little bit in that since February last year, oil and gas boilers were banned. Anything that emitted carbon dioxide at the point of use. So typical boilers in new homes were to be banned. which really for Scotland only really leaves you the choice of direct electric heating and heat pumps or district heating once these systems become available. So that's a really brief summary of the EPC and the SAP calculation, which are things that you'll hear if you go through the house building process. Is that enough to cover on energy performance, Fraser, without getting too bogged down?
I think so, yeah. We'll touch on a lot of these systems later on as well.
Yeah, very easy to get bogged down, so I'm keeping my best not to.
There's a lot to cover.
Yeah. So I don't know if many people have heard of Passive House. I think most people have heard something about it. It's a German standard for building houses, which incorporates very high standards for ventilation, heating, U values. And at the moment, we're in the consultation stage, but it looks like by the end of 2024 in Scotland, we may be moving to a Passive House type standard in Scotland. I mean, everything is a little bit up in the air just now with what's going to happen with future green policy, but we're assuming that that we're still going to be going down that road. In terms of what it will mean for Scottish building regulations, the fabric U values that we have to meet anyway are already very good. Windows and doors may have to improve slightly. They might be triple glazed if we go to this Passive House type standards. Solar gains, which we'll talk about a bit later, they may be improved slightly. Air tightness is something that's likely to be will have to be improved on. I mean, it's already pretty good, but that's likely to get much tighter. But the biggest thing is probably what we refer to as the performance gap between how a house is designed and how it's then actually built on the ground. Passive House has quite a strict system of certification to prove that actually what's on paper does actually happen on the ground. And so this might be quite a big change if these plan changes come through. In terms of additional costs, traditionally people always used to say that building to Passive House standards would add about 10% to the cost of building your home. But this was probably based on building standards 2, 3, 4 years ago. But because we're now building houses to a much higher standard, and we're already getting closer to Passive House, in terms of the insulation and all the other factors that you're looking at when you're building a house, that gap has shrunk quite a bit. So it may be that gap is perhaps only somewhere between 1 to 4%, something like that. And really, the big difference we're going to see soon is not so much how the house is actually built, but more of the process and the certification process of how you can actually prove that a house has been built, and that there's a cost to go through a Passive House process. So that may be one of the bigger costs. So actually, in terms of just the house itself, there may not be a great deal of difference. We mentioned air tightness there. At the moment, we're finding that HebHomes are, Fraser, would you say between sort of 1 and 3 as a figure?
Tested, yeah.
So every house now has to have what's called a blower door test, where you seal the house up, you pressurize it or depressurize it. Both tests are done, and then you switch off the blower door and you see how quickly that house returns to the ambient air pressure outside the house. And the better it holds that air pressure, the less drafty or the less leaky the house is. So the lower that number, which is measured in cubic meters per hour per meter squared, which is not a particularly helpful measure, but it gives us this number. And at the moment, we sit between, say, 1 and 3 for most HebHomes builds. That's probably going to have to improve to about 0.6. So that will be quite a change if we go to a Passive House standard. That'll be a big change. For U values, which is the conductivity of the floor, the walls, and the roof, how good they are at retaining heat. They probably won't change a great deal because they're already pretty good. The walls might have to improve just a little bit, but there's not really much movement to improve roofs and floors particularly. So unlikely to see much change there. So yeah, I think that's probably don't want to kind of go too much more into the whole passive thing, particularly when we don't actually know what's going to happen in Scotland.
Yeah,
it's
it's
all
all quite.
slightly
We're just
guesswork just
guessing
now.
at the moment, aren't we?
Yeah, exactly. Yeah, but these will be some of the features anyway if we do make these changes.
Well, it's interesting that air tightness is probably going to be the one that they really clamp down on. So there's probably things that need to be improved there. But as you say, the things are the systems are very, very close to meeting that anyway. There probably will just be, it's when you get down to that tightness, it's the building fabric when you're like putting nails through and you're putting services through the walls. That's where you need to really focus on and really do a run through. And I think generally the air tightness test is usually done towards the end of the process, Robin, isn't it, rather than throughout?
Yeah, that's right. Yeah, because there's a cost to it, and everyone has to go off site and leave the house while it's being tested. So it's an interruption. Passive house like to talk about having a. They say that when the builders are building the house, they need to have somebody who's assigned as the kind of policeman. They're going to certify that they're almost there, just going around watching what everyone else is doing, making sure that somebody's not stuck a screwdriver through the insulation and created an air gap. So it's kind of that process. But I mean, I don't know if you find this in reality, but there appears to be more and more builders who are getting better and better at building to the standard, and it's now just an accepted thing that you have to use tape to seal up any joints. When you take a pipe or a cable through a wall, then you have to seal around it. You don't just create a hole and forget about it.
Yeah, I think you're certainly right. I think, Robin, because contractors do need to be more aware of this, because as we say, the test is usually done right at the end of the process when the build's finished. So you really want to make sure that if you're trying to hit a certain value, you're hitting that, because the risks are that the value is too high, and it means that your ventilation system isn't as effective. So I think contractors generally are much more aware of their obligation and their duties to make sure that they do build to that quality.
Yeah, as you say, once the plasterboard's gone on, it's been decorated.
Yeah,
and there's nothing you can do other than tear it apart, and that's hugely expensive. So it's just not going to happen. So
no. Okay, let's move on. Okay, do you want to take the lead on that, Robin?
Yeah, that's fine. Yeah, and again, I'll apologise. There's lots of detail in this, and I've tried to just condense it, just a few kind of comments for each one, and it may well be there's lots of questions to ask a bit more detail about this. But okay, so air source heat pumps essentially move heat energy from the air outside of the house into heat inside the house. They're measured by something called a SCOP, which is a seasonal coefficient of performance. There's a number which is applied. With a normal boiler, a gas boiler, you might get efficiency of, say, 95%. So every unit of energy you get in, you get 90% of that going around the house. You get an uplift with heat pumps. So if you put 1 unit of energy in, you should get at least 3 units back out. So you get more like 300% energy efficiency, and that can rise to 400 or 500 depending on how well the system is designed. The heat pump unit, it sits outside, does create a little bit of noise. It also needs to be relatively close to the house to be efficient, so you can't just stick it at the foot of the garden and cover it up. And one of the key things about them, they operate they'll produce hot water to go around your hot water system, your heating system, with a lower flow temperature. So a gas boiler might provide water at 65 degrees, 70 degrees to go around your radiators. For heat pumps to work more efficiently, they run at lower flow temperatures, more like 45, 55 degrees, which is why quite often you hear people saying, well, you have to have a larger radiator for a heat pump. So that's essentially heat pumps, air source heat pumps, without going too far into it. Ground source works pretty much the same way. It extracts heat from the ground, either in trenches in the ground or in very deep boreholes, which are drilled next to your house. They're a lot more expensive to install because of this, but they have similar efficiency to air source heat pumps. They don't have a fan, so they're a bit quieter, and the unit sits inside the house rather than the air source heat pump unit, which sits outside. That's ground source heat pump. There are available grants for new build houses. As far as I know, in England and Ireland, it's the same as Scotland, which is for second homes, holiday homes. Don't believe that grants are available. At least they've not been available in the past. But for a primary primary residence. I think it's £7,500 available to help with the installation of heat pumps. I think you can get us 9,000 for qualifying rural areas in Scotland, but it's a similar figure for Scotland, England, and Ireland. Underfloor heating it's something that works quite well with a heat pump. You basically have the underfloor heating coil under the floorboards, which gives you a kind of a steady, kind of comfortable heat right through the rooms, rather than lots of heat at the radiator, relying on convection to move that warmer air through the room. Can be a little bit limited by floor coverings. Tiles and some wooden floors work better. Obviously, if you have a surface on your floor which is insulating it, it's more difficult for the heat to come through that into your room. So that does need a little bit of consideration. And a criticism in the past has sometimes been, with a radiator, you stick on your boiler, turn your radiator up full, you get heat very quickly. Whereas underfloor heating likes to work. They're accused of being less responsive because, again, they work with a lower flow temperature. But actually, with a modern house which isn't losing heat through the walls and the roof and the floor very quickly anyway, there's much less of that sort of slow response time, so that's less of an issue. A bit more expensive to install than radiators, but I think for a lot of HebHomes customers, we typically recommend underfloor heating for ground floor. Very little heating on the first floor if it's a two-story house, because the heat will circulate. But we usually suggest towel radiators in the bathroom, just for a bit of additional heat and for drying towels. So moving on from that, which I was saying about the heat circulating through the house, another feature we're seeing almost always now with new builds, with HebHomes new builds, is mechanical ventilation with heat recovery, or MVHR. Because we're now making houses relatively airtight, so that we're not losing the heat through the walls, which is great. The downside is that we're not getting fresh air blowing through the house. So what an MVHR unit does, there's a unit that sits, a bit shaped, its size a bit like a boiler. It sits in a cupboard or utility room, and it delivers fresh air to bedrooms and living rooms in your house, and removes stale air from the kitchen and the toilet and bathrooms by a network of ducts which are hidden in the ceiling voids. It improves air quality a lot. It'll remove carbon dioxide from building up, and also remove humidity, which can be an issue. You can still open windows with an MVHR, and that's something that some people have a concern about, that they're going to be living in this sealed box. So it's not the case. You can open windows, and when you're most likely to want to open windows, I would say, is in the summer months, when heating is less of an issue in the house. So you can absolutely open windows and doors if you want to. Because there's the heat recovery side of MVHR. The way that works is there's a heat exchanger within that unit that sits in your cupboard, and as the exiting warm air leaves the building, the heat exchanger transfers the heat into the fresh air coming in. So you're not just pumping out all this air that you've heated outside. You're pumping out the stale air, but you're hanging on to the heat from it. So that's the important bit of the heat recovery. And at the moment, with Scottish regulations, I mentioned these numbers, the air tightness. Once we get below 3, and at the moment 7 is the worst you're allowed to build to in Scotland. Once you're at 3, which I think all HebHomes builds I've ever seen have always been better than that, you have to have MVHR. The risk is if you don't have that, you get stale air in the house. You get condensation building up, and condensation can lead to condensation and mold. So it's a really bad thing.
One thing to add to that, Robin, is there is always this question: can we remove the MVHR to save money, and completely rely on natural ventilation?
Yeah,
and it's really, really difficult to do that now, because the houses are so airtight that they usually do need some sort of mechanical ventilation. Usually mechanical ventilation with heat recovery is the most effective way to do that. But the risks are that you decide not to put in NVHR and you're hoping to achieve natural ventilation, then you need to wait until the end of the project, essentially, until it's complete, till you can get your air test done. And that air test needs to come back at, is it above 5, Robin, that you need to achieve? I think it's something around there.
That's right. Yeah, between 3 and 5, you can use fans that are a little bit like your bathroom extract fan, but they basically run continually. So that they're called decentralized mechanical extract ventilation. So you can use that between that sort of intermediate area. But yeah, essentially, if you want to use natural ventilation, you basically have to knock holes in your walls to make your house draftier, which is obviously a little bit perverse if you've built the house to this high standard, and then in order to make it safe, you have to then create more draft. So you're going to lose all that heat through the draft. So it doesn't make a lot of sense. I think there is some resistance with NVHR because there is a cost attached to it, and it's a slightly odd idea to have that in our homes. We're obviously very used to it in commercial buildings, but I think that will change, just as we're getting more used to heat pumps now, and the idea that we're not going to have gas boilers. I think NVHR is going to become far more accepted as something you just have in homes.
Yeah. And do you want to just touch on solar PV and batteries as well, Robin, on this slide?
Yeah, that's fine. I mean, I suspect most people, most of you got a pretty good idea about solar PV because it's been around for quite a while now. The costs are falling quite a lot, so it's much cheaper. The cost of panels has just fallen and fallen. In terms of a PV array, normally without applying for permissions, you can get up to 4 kilowatts of power. So that is about 8 to 10 panels. So that's about kind of the maximum you can usually have on the roof or on a ground array, unless you want to apply for permission to go for a lot more. And occasionally we do see that. Obviously best in the south-facing roof because they're going to catch more of the sun. They can go on a flat roof or a pitched roof. So it can be either. More often asked about payback. Typically see payback around about sort of 4 to 5 years, something like that, depending on a whole range of factors, but payback quite quickly. And solar panels, when there's no moving parts, the warranty on panels can be, or the expected lifespan can be up to 25 years. So financially it can make a lot of sense. And the power that they create can be used as electricity for running things in your home. It can be diverted to heat hot water, or it can be used to charge a battery, or it can be sold back to the grid, albeit there are some tariffs from some of the energy suppliers that are giving better rates for selling electricity back to the grid, but typically it's not, you don't get a lot for it. It's not particularly attractive. So it's better to use the electricity you generated on site. And then batteries are a bit unlike solar PV are still quite expensive, and as a result, they've got a longer payback period. What we're tending to find, I mean, it's changing quite fast, and there are some batteries that are much cheaper than something like the Tesla Powerwall, which is one of the better known and better quality batteries. We're tending to find that a payback might be something like 8 to 10 years, which is not that dissimilar to the warranty or the expected lifespan. So I think it might be quite different if batteries, if they keep dropping in price the way that solar PV panels have, then batteries could become really attractive shortly. But right now, our advice to people generally, if they're saying, well, should I put a battery in, is put in the wiring and have the infrastructure there, but perhaps don't fit the battery quite yet. Just wait to see what happens to prices. Another argument for having them, though, is if it's a rural property and there are power cuts and there's an issue with supply, then a battery can be good as a backup system. So that's possibly an argument aside from the feeling of when is it going to pay for itself.
Yeah, well, it seems that PV panels work really quite well alongside air source heat pumps, and they also usually have they will have a hot water storage tank, so that kind of acts as your thermal store as well.
Mm-hmm.
And a lot of the majority of our clients will go for some sort of heat pump. In general, it's an air source heat pump, with your underfloor heating. As Robin mentioned earlier, you usually need a bigger radiant surface to radiate the lower heat that you get from the air source heat pump. So underfloor works really well with it, and it's a really nice way to deliver heat. You don't have, with radiators, it's all down to convection, so a lot of your heat ends up in the ceiling. Whereas you have a lower temperature being emitted from the floor, you just generally feel much warmer. So the room doesn't necessarily need to be as high a temperature as it would if you had radiators. So they work really well together. And as we say, MVHR, we've got that in pretty much every job, to be honest. Just means that there's less risk involved to make sure that you've got enough ventilation within the house when it's actually built. And quite a lot of our clients do go for PV panels as well. So it's an all-electric system now, completely moved away to, I can't remember the last, we've certainly never done a gas boiler in one of our houses, but that I can remember. We've been electric for a long time now, so they do work very well. And as I say, most of our clients, do specify these systems, and they're always progressing. And I think there will be a big drive towards heat pumps, and there already is, but there's a lot of development in that sector. So we'll just see these systems getting better and better as they roll out more and more units across, especially the old building stock as well, when they're fitting heat pumps to existing buildings. And that's something we'll probably see in the next kind of couple of decades. Which brings us on to a tricky topic, which is kind of come out in the last couple of months in Scotland. So it affects Scotland just now. It may well eventually trickle out to England, Wales, and Ireland. We don't really know what's going to happen. And to be honest, in Scotland, it is still quite vague what's going on with stoves. But a lot of people have the dream of moving to the countryside, building a beautiful house, putting a stove in it, and putting the fire on a rainy day. And it is a lovely way to heat the home. Quite often they are decorative. There's no real need to put one in apart from it's a nice to have. And certainly we're still installing them on projects, and people will put them on really cold days just to boost the temperatures. And it's a really nice feature to have in your big living room. Now in Scottish projects, the government has basically said you can't install a wood-fired appliance as your primary source of heat. So that also affects biomass as well, Robin, I think, doesn't it?
Yeah, biomass is banned. Yeah.
And stoves as well. So they don't want, you can't specify a log burning stove as your primary source. And there's still a lot of dubiety about, can you have it installed as a kind of secondary source? And basically what it sounds like is a lot of the councils are going to accept if you are in a rural location, you can argue that that's a backup source of heating. So if your electric drops out and you have a power cut, then you've still got a means to actually heat your home. But a lot of this has come out of a lot of research in the last couple of years about the emissions caused by log burners and the particulates that come off it. And you do have areas in Glasgow, Edinburgh, and other areas of Scotland that have smoke-free zones. Previously, you were able to specify a stove that was essentially was classified as smoke-free just from how it burned. So this is an area that we are currently monitoring. But what we're doing just now is we are showing stoves. If one of our clients wants a stove, we'll continue to show that in the plans through planning. Planning are going to be fine with it. It's when you get to building control, that's when you're going to have the questions that are raised, because that's when we're working with Luths on your SAP calculations. And we used to always show stoves, but I think the new guidance is we just don't show it. It's just a kind of decorative thing, Robin, isn't it?
Yeah, that's right. I mean, you can only enter a wood burning stove in SAP as the primary or the secondary form of heating. So at the moment, we are being told you can put a wood burning stove in for emergency use only, but we haven't been told how you define emergency rather than secondary. But so one of the council's building standards department, building control departments has said, well, just don't put it in SAP. There's nowhere to record it because you can't record it as emergency. So we're just going to allow it to go through because it's not in the SAP. So it's a bit of a fudge, but yeah, I think some building control departments are saying, well, yeah, you have to use that as a backup in rural areas especially. So
yeah, and it's difficult because a lot of the councils, the building control offices and the councils, will look at that regulation and interpret it differently. So I think even within the councils, they're confused. They don't really know exactly what they can and can't approve. But from our preliminary discussions anyway with a lot of building control officers, it seems okay in a lot of the areas that we're building in Scotland. So as I say, we'll continue to go on the basis that we'll show it in planning, because planning aren't going to be concerned if you show a stove in planning and you don't actually put a stove in. That's not going to bother them, because you obviously have a flue coming out the top of your roof. Whereas it's more difficult going the other way, installing a stove and then having the flue. They would probably ask for an amendment. So we're better just showing it in planning for now. And then we will battle the case. If you want that stove, we'll battle the case with building control. But it's just to kind of flag that could potentially be an issue, if we get to that stage. And if it is an issue, we just simply remove it. We remove it from the plan and elevations in order to get your building warrant. Generally, the stoves that we specify are small anyway, so generally it's under 5 kilowatts, because you really wouldn't want anything bigger than that in any of our houses. Even the big Stedgens that have a really big living space, that'll heat up really quickly with a 5 kilowatt stove. And in terms of direct air feeds, it's not necessarily required, but it's beneficial to have a direct air feed to the stove, especially when you've got things like MVHR, so that you've got a kind of closed shell of a building. It's good to be able to draw oxygen into that stove from outside. So generally, that's what people will tend to do. So yeah, really all we can do is watch this space with stoves in Scotland. As I say, in the rest of the UK and Ireland, currently seems to be okay, but things are always subject to change. So we'll just keep an eye and see how we get on with it.
There's a really strong argument when we're being pushed to use air source heat pumps. There's a really strong argument for that you have to have some emergency backup heating, because when we size heat pumps, and that's a really important part of making them work efficiently, is having them sized correctly. We don't size it so that it will cope with 100% of the potential weather. So it may well be your heat pump could cover you down to, let's say it's -5 degrees, but on the days when the rare days when it's colder than that, having an emergency backup is a really good thing. And this is what they do in Scandinavia, where they have heat pumps that work perfectly well. They have wood burning stoves for those cold days just to back it up. So it's a really hard one for the Scottish government to say you just can't use them at all. And
I'd be surprised
what emergency means. Yeah, I think so.
I'd be surprised if they did completely outlaw them, to be honest, because they are very beneficial to have. They do have the function, so
yeah,
I'd be surprised if they did kind of take a hard line. But yeah, time will tell. I mean, we submitted a few building warrants in the last couple of weeks with stoves, so we'll see how that goes. But it will be very dependent on what council we're actually submitting for.
Yeah.
And this is our final slide. Robin, do you want to take the lead on this solar gain?
Yeah, that's fine. Yeah. So solar gain is it's a good and a bad thing. Basically solar gain is just heat from sunlight transmitted through the windows. On cold, sunny days in winter, solar gains are a great thing because they can actually provide quite a lot of heat for the house. In summertime, they can give us a problem with overheating, though, with homes being less drafty and better insulated, and with large areas of glazing. We are now seeing houses failing overheat studies, which is a part of the requirement of the building warrant now. Before we thought of it as being a problem for kind of the south of England, where it's a good bit warmer, but it is now an issue in Scotland. And previously there was a very small part of SAP which dealt with overheating, and it was almost a couple of tick boxes. Can you open windows in the house? Yes. In the majority of cases, that was enough to make it pass an overheat test. But the building regs now have taken that out of SAP, and it's now a whole new area. So we need to provide reports to back that up. I'll come on to that. So the things that can impact on the overheating of a house, one is the orientation of the building. So if it's mainly south facing, and there's lots of south facing glazing, then there's much more chance there's going to be heating from that. One way to counter that is solar reflective glazing. All glass has what's called a G value, which tells you what percentage of the heat hitting the window will actually be transferred in. And as I said before, there's a good and a bad side to this. So if you've got a very low G value, that's probably great in summer because it's going to reflect back quite a lot of that heat and stop the house from overheating. But you're then going to reduce the benefit you get in winter time. So you're going to have to heat the house more rather than take advantage of the heat from the sunlight in winter time. So there's a bit of a balancing act with this G value. Another way to prevent or reduce the solar shading, and this is a really popular thing with passive house, is to have shading outside the window. They talk about these design features called brise-soleil, which is almost like a louvered timber canopy that hangs over the window. And the benefit to that is in winter time when the sun's quite low in the sky, the sun can still hit the window and transfer the heat in. But in summertime when the sun is higher, the louvered brise-soleil canopy then stops that sun from directly hitting the window. So that's one way to do that. And external shutters and external blinds are other ways just to cut down on some of that heat. Again, things that we see all the time in some European countries, but have been less of a feature, certainly in Scotland anyway.
We found particularly upstairs because particularly in our longhouse and steady ranges where you've got the upstairs and basically in the coombe space, and because it's a story and a half, you've got these roof lights which sit at 45 degrees, which is almost perpendicular to the sun. So you do get quite a lot of solar gain through that. So particularly like on this image, you've got a lovely big double width roof light that can get quite hot. So through overheating analysis with Robin and his team at Luths, we can identify if that will be an overheat risk. And for these roof lights, they've got Velux have standard products that can be attached to the outside. So it can be a simple external kind of roller blind, or it can be a solar controlled metal shutter. So there's a few options there should we need to use it.
Yeah. Are you finding, Fraser, are all building control departments now insisting on an overheat study? Because again, this is partly down to the interpretation, isn't it?
Yeah, just a simple one. Sometimes we're asked for a dynamic analysis, but generally we'll allow for a simple analysis in all projects anyway. Because generally it's asked for. Yeah,
and the simple one's quite a straightforward bit of work. We look at the geometry, the orientation, the window sizes, this solar reflective G value that I mentioned. And if this just generates a tick that says, okay, each room's not going to overheat past a certain degree, then that can be enough. And yeah, we can do this dynamic study as well, where we're able to look at it in more depth, and we can produce an hour by hour study for each room, and it allows us to identify which rooms are the problems, and then exactly in a lot more detail, how do we solve that? And do we open doors? Do we need to reduce the size of one window? Can we put a solar shade on this? And I think what we normally suggest is if we are at the stage where you're thinking, well, we're going to have to start resizing windows, spending money on improving it, the dynamic test might be worth doing, because it might save you money, because we can look at the smartest way to solve the problem. I mean, like with a lot of these things, there's a regulation side of it. You need to pass the regulation, but with overheat, there's definitely a practical side as well, which is you really don't want the house overheating. Yeah, I mean, both in terms of comfort if you're in the house, and also so there's not actually damage caused by veneer panels warping and kitchen units suffering damage and heat if it's a holiday home which is just building up heat over the summer. So
yeah, it's something we need to be careful of, because we do in our homes, we want you to take advantage of those lovely views and have a really nice, bright and airy space. So we do always have, on all our designs, we've got really nice big floor to ceiling windows. So we just need to make sure that there's no complications or implications with that. So that's why Luths help us with the overheat analysis as well, just to make sure that there's no issues, and it is a really comfortable internal environment the whole year round. you don't want to just capture that house, you know, in 1 month of the year. You need to see how it's going to work throughout the year, and that's where Luths come in and really help us design that and make sure it's going to work very functionally. Right, we've come in exactly on time, Robin. We've got a few questions to go through, just a handful, and then we can wrap things up. First questions on installation options for the CPS system. So the CPS, yeah, so we're actually currently in talks with a new supplier, and they offer a really nice system, which is a closed panel system that uses recycled glass insulation. So it's a really good option. So as I say, we are in discussions and we're near to finalising things with this new supplier. So it's a really exciting new proposition, because it means that we can offer this fully closed system that uses insulation that's not derived from fossil fuels. Essentially, it's not an oil-based fossil insulation. So we can discuss that. We've got some clients that have space frame systems specified, so that there may be an option to move over to this new system. We've got one. So heat pumps. So the grants for heat pumps, are they not old when it comes to replacing oil or gas boilers, at least in England? So I know that it's called, what's it called in England, Robin? Can you remember? It's the gas boiler replacement scheme or something like that.
Oh, it's the boiler upgrade scheme.
Yeah. So does that still applies to current projects that are installing air source?
Yeah, as far as I know, yeah, I think for at least a couple of years, yeah, if not more, I think that scheme's still in place.
Yeah, yeah. So it'll be good. There's various different organizations out there that will help you get grants. They'll help you understand what grants are available for your build, and particularly around heating systems, that there are usually grants or loans available to install those systems, just to help, because these air source, well, heat pumps in general are generally more expensive than, for example, a gas-fired appliance. But obviously in the long run, it's going to be a lot cheaper to run. So it's a bigger upfront cost, but a much lower operation cost. And particularly when, you know, gas and oil prices are continuing to go up, and they will continue to go up for the foreseeable, presumably, it's a really good option. We do have a question about heat pumps, about their efficiency not being great, and why are we still promoting them? So heat pumps, they are getting better and better, and as I say, most of our clients use them in some sort of format, whether it be air or ground source, and they are constantly improving. But our clients seem to really like them, and they do really well. There's not really many alternatives, Robin, are there, to heat pumps or direct? Because the alternative would be just panel radiators on the walls, wouldn't it?
Yeah, I mean, if you're avoiding fossil fuels, which you have to in Scotland certainly, if you're restricted to electric, then really you've only got the option of direct electric, which means it's going to be expensive, because electricity is expensive compared to gas. It's 3 times the price, and if you can only have 100% efficiency, or 90 something efficiency, then it is going to be expensive. A heat pump, if it's sized properly, and that is a really important part of it, is sizing it well. And if you put in a heat pump which is too big, for instance, and that used to be, I believe, that was an approach with gas boilers. You put in something that's a bit bigger, and it'll cope with all the needs. But it's more important with an air source heat pump that it is that it's sized correctly, and then the whole system is built properly. So the unit is placed correctly outside. It's not too far away from the house. The pipes are all put in correctly in the right way. The radiators are the correct size. So yeah, I mean, I think there are horror stories of heat pumps having been put in badly, poor quality heat pumps installed incorrectly, with poor controls. And so, yeah, there are people who've got stories of, the system's just been dreadful. But if they're properly installed, there's absolutely no reason why they should be like that.
Yeah. There's another question on what air source heat pumps do we use? So we don't necessarily use them, but you would usually specify, as you would specify the size of a heat pump in the SAP, Robin?
Yeah, the work that we do for you is if we do the options appraisal, we can also do an alternative kind of cut down version of that, which is just literally just sizing the heat pump. So we can do that, but all that will do is give you it'll give you a size. So it might say, right, you need a 5 kilowatt heat pump. If typically, and we are sometimes asked to do this, do a separate project, say, right, well, I want a complete document to hand to the contractor to say, this is the MVHR unit I want, and this is how I want everything built. And same for the air source heat pump. Typically, we find, I think with most of the contractors you use, they're actually quite comfortable with the heat pump that they install. They know where to get it from, how to install it. So all we do in effect is just say, it's a 3 kilowatt heat pump or 5. But that number is quite important to get that number right, and then have a contractor who knows how to fit it well as well. But brands like Valent and Mitsubishi are two of the bigger names that we see regularly fitted. So
yeah, that's the main thing, making sure it's installed properly. And generally, you'll when you are going through the build process, that is a portion of the build that your contractor will manage, but usually it's a subcontracted element, so that they would probably use a specialist local installer to install that heat pump. I did show an image of a plant room, a really bad picture, but it shows you all the gubbins that go along with these systems. So your water tank, an expansion vessel, if you've got underflow heating, you've got a manifold. So there's a lot of things that go along with those systems. It just gives you an idea of all the kind of plant room requirements. But that is designed by the contractor largely, alongside any specialists that are required. This is a good question. Obviously, someone that knows what they're talking about. Higher temperature heat pumps becoming more available that can work with existing radiators. Now, I think isn't there an energy supply that has come out with a high temp heat pump recently, Robin?
Yeah, I think the Octopus have actually. There's quite a bit of development in it, and yeah, they are getting better, definitely. And obviously the higher, I mean, a heat pump can provide water at a higher temperature. The problem is the efficiency drops off, and there's that SCOP figure that you just want to have as high as you possibly can. As I say, kind of closer to 500% is being achieved with kind of well-designed systems. But yeah, if you push that water temperature up, the risk is that efficiency drops off. But yeah, newer systems are getting better at coping with higher temperatures, because obviously the benefit is you don't have to put in new pipes through your house, you don't have to put in bigger radiators, because these things are, just adds cost and inconvenience, and you don't particularly want to have a huge great radiator on your wall. So yeah, things are changing quite fast. We're still only seeing a tiny number of heat pumps being installed compared to gas boilers still. But once that switch starts to happen, then there's going to be even more development, because the market will just get bigger for them. So
yeah. Okay, that's great. Okay, we should probably try to wrap up now. There's one more question. There's a few more that we probably won't get through, but the webinars about running through the building project and when you actually make your choices for heating systems and processes and timeframes. So we've got a webinar schedule on the website. So if you go to guidance and then company webinars, you'll see all the planned webinars coming up. So you can plan to be at each one, and we'll also send invites as well prior to it happening, so you know what's coming up. But I think we should try and wrap up there, Robin. Thank you very much for all those insights.
It's sorry, it's a bit of a download with information. There's quite a lot to cover.
There's a lot to go through, and it's a big topic, and it's really good to start thinking about all these things before you start on your self-build journey. So I really appreciate you joining, Robin. Thanks again.
No problem at all. Good to see you.
But yeah, hopefully that has been informative. There will be topics that we've not managed to get fully delved into, but hopefully it'll just trigger that kind of initial thought process of all the things that you think about before you start on that process. So if you'd like to get in touch, you might already have a plot, you might be looking for land and have identified something, and you are really looking to move forward to the next steps, then please do get in touch. You can either get in touch with myself, Fraser at HebHomes.com, or my colleague Lindsay, and she can set you up with a meeting. But we can see what we can do for you and have a look at your plot and discuss your requirements for the design and the build. So yeah, hopefully you've enjoyed that. Thank you for taking the time to come and see us and spending your lunch listening to us talk about heating and ventilation. But yeah, hopefully you can join the next one. As I say, end of May, we'll be sending out the invites for the next one. So thank you very much again, Robin, and I'll speak to you soon.
Cheers. Good to see you. Bye, Fraser.
You too. Bye-bye.